All right, so now we are going to move on to the last video of section 7.5, and that's going to be solving logarithmic equations. All right, so logarithmic equations is where now we will have a logarithm and our variable will be part of the log base 10 of x, or a variable will be there and be equal to, say, 5. All right, now we know our exponential and logarithms are inverse operations of each other. So in order to solve this, we're going to have to take the exponent of each side, or create an exponential equation on each side. But unlike our last problems where when we just wrote log on each side, we didn't have to really think about it. When we do this and we go to solve logarithms, we have to pay attention to this base. And whatever that base is what we're going to have to use on both sides. So let's go through an example, or a couple of examples, so you can understand what I'm talking about. All right, so here we have log base 10 of 4x minus 3 is equal to 2. So if we want to solve for this, what you need to do is you need to identify what our base is, and our base is 10. So what we do is we essentially are writing each equation as that base raised to this logarithm is equal to now that base raised to this answer 2. So since, as we talked about in videos before, since we have a logarithm and an exponential with the same base, they undo each other and they cancel each other out, and we're just left with 4x minus 3. 10 squared is 100. So now we have 4x minus 3 is equal to 100. We add 3 to both sides, so we get 4x is equal to 103. And then we divide each side by 4, and we get x is equal to 25.75. Right? That is our final answer. And if we were to go ahead and plug this back in to our original equation, we would have log of 4 times 25.75 minus 3. And does that equal to 2? Well, we would have log of 103 minus 3, does that equal to 2? So log of 100, does that equal to 2? Now we could rewrite this as an exponent, so we know our base is 10, so we can say 10 raised to the second power, does that equal to 100? 100 is equal to 100, yes. All right, so you can always check your work. All right, let's go ahead and do another example of this. All right, so we have log of 3 minus 2x is equal to negative 1. For this, you identify your base, which is 10. So then we're going to raise 10 to use 10 as our base of our exponent on each side. This will then undo each other, so we're left with 3 minus 2x is equal to 10 to the negative first power, which is then 1 over 10, or 0.1. So then we would have, so let's just rewrite it as 3 minus 2x is then equal to 0.1. So then we'll subtract 3 from both sides, and you get negative 2x is then equal to negative 2.9. And then you'll divide each side by negative 2. And then you get x is equal to 1.45. Right? And then that's your final answer. And you can check this and test this by plugging it in to your original equation and see if you are getting a true solution. All right? Now there's one more example that we're going to go through. All right, now this example, the first thing that we have to do is we have to use our logarithm properties. And this plus, since we have the same base 10, means that we need to multiply these two together. So we would then get log of x minus 3 times x is equal to 1. So then we would distribute this x in. So we get log of x squared minus 3x is equal to 1. So now to solve for this, we would then find our base, which is 10. So that's the base we need to use for our exponents. So this is going to undo each other. And now we're left with x squared minus 3x is equal to 10 to the first power, or 10. Now when we're doing this one, we have an exponential equation. I'm sorry, not an a quadratic equation. So now we need to set it equal to 0. So we'll subtract 10 from both sides. So x squared minus 3x minus 10 is equal to 0. Now we will factor this. And remember, this minus sign tells us that our signs are different, so it's x plus and x minus. Factors of 10 have a difference of 3. Well, it's 5 and 2. Since this number is negative, our larger number needs to be negative, so it'll be x minus 5 and x plus 2. So we would set both of these equal to 0 and solve for x. So that means x is equal to -2 or x is equal to 5. And when you solve problems like this, you need to check these answers and see, do they work? All right, so log of -2 minus 3 plus log of -2, does this equal to 1? Well, we can't take the log of a negative number, so this can't work. So we know -2 cannot be a solution. So then we would check the other one. Does log of 5 minus 3 plus log of 5 equal to 1? Well, this becomes log of 2 plus log of 5. Does that equal to 1? Since they're adding, we can go ahead and multiply. So it becomes log of 2 times 5, or 10. Does that equal to 1? And we can rewrite this as exponential with the base 10 to the first power. Does that equal to 10? And yes, it does. 10 does equal to 10. Check. So we know that this answer works, whereas this answer does not. So we would reject -2. It's an extraneous solution, and our only solution is x is equal to 5. All right, that's it for this video, and that is it for this section.